This is our fifth lecture from chapter 12. We have one more after this on nuclear fission. And today, though, we're going to talk about the last of our fossil fuels, which is natural gas. Now, natural gas. What is natural gas? So basically, natural gas is a naturally occurring gas. It forms in pockets above oil deposits, sometimes in coal beds, or it can actually exist as just natural gas by itself. So we see natural gas associated with oil and coal, which is where we first discovered it, but we're also discovering now that it can be trapped in rock on its own. Now, the gas used to be burned off as waste. We didn't know what to do with it. We didn't realize it was a fuel, and it was considered dangerous because it's explosive. But now we collect it as its own resource, and it's sold commercially. Now, natural gas is made up mostly of methane, which is CH4. There's also some ethane, which is a 2-carbon chain, propane, 3-carbon chain, and butane, which is a 4-carbon chain. And then these are all mixed with hydrogen sulfide, which is a highly toxic gas. So one of the things with natural gas is that we have to be kind of careful. They do try to scrub out some of the hydrogen sulfide before selling it to consumers, but if you're working with it as it occurs naturally, you've got to be careful to make sure that you aren't going to get poisoned by this. And like I said, it's also flammable, explosive, so it's something you want to be careful of. Now, natural gas, in order to transport it, they can pipe it just as a gas. So there are long pipelines that extend across different parts of the country and the world where they insert natural gas and they pipe it all the way along. Natural gas can also be compressed. So you'll see some vehicles run on CNG, which is compressed natural gas. Or it can be converted into synthetic gasoline, which is much more expensive because you have to actually make it undergo some chemical reactions so that the carbons will fuse together to form longer chains. Because gasoline is actually a 7 to 8 carbon chain, and 6, 7, 8, but mainly 7, 8. And so got to make sure that if you're going to be making gasoline out of it, you're actually trying to take 1, 2, 3, and 4 carbon chains and smash them together hard enough that they make a 7 carbon chain. It's a little bit more energy intensive and expensive. So, real quick quiz question just to make sure you're on the same page as everyone with natural gas. Natural gas is composed of all of the following except, is it A, methane, B, propane, C, ethane, D, butane, or E, sulfur dioxide? Now think about that carefully. Go ahead and pause. And when you're ready with your answer, you can continue. The correct answer is E, sulfur dioxide. Now, this one was intended to be a little bit tricky. Now, methane is a 1 carbon, CH4. Propane is 3. Ethane is a 2 carbon chain. Butane is a 4 carbon chain. And natural gas does contain a sulfur compound, but it's not sulfur dioxide. It's actually hydrogen sulfide. So if you can remember this, natural gas doesn't really contain any oxygens in it, not in a large, for the most part. So no oxygens. Sulfur dioxide has oxygen, it's SO2. Hydrogen sulfide is H2S. So hydrogen sulfide is the one we have in natural gas, not sulfur dioxide. Sulfur dioxide would be a product of combustion. All right, so this picture is the same one we had in our oil lecture, but it's just showing you right there how natural gas can occur trapped along with an oil deposit. You can also have natural gas trapped within coal deposits, and then, like I said, it can be trapped by itself in shale, which is one of those, you can see there's the shale cap rock and the shale source rock. Well, if little microorganisms become trapped as the shale is forming, then their decomposition, or even as trapped in the sandstone, the decomposition of those microorganisms in the absence of oxygen can lead to the formation of natural gas. And then as the natural gas forms, it will work its way up as high as it can through the different layers of rock and usually becomes trapped in shale. All right, so world reserves. We have about 1/3 of natural gas reserves in the Middle East, which makes sense because the Middle East has 65% of our oil, so they have the type of geology where natural gas occurs. The US owns about 3% of the world's natural gas, which is about a 75-year supply. And these numbers are being modified a little bit as we discover shale gas, which I'll talk about towards the end. At current production, the world supply is expected to last about 75 years. So if you guys can remember these numbers, coal we're expected to last about 300 years, oil is expected to last about 50 years, and natural gas is expected to last about 75 years. So you can see why people really are investing or looking towards coal as one of our fuels of the future, because it's actually one of the longest lasting ones, or one of the ones predicted to last the longest. And if you look down below, the major consumers of natural gas, the graph is showing consumption of natural gas. North America and the former USSR, we consume 55% of the gas used in the world. There are other countries like China, India, Australia, Mexico, Argentina, some of the Middle Eastern countries that also consume quite a bit. And then you can see just by the color scale, orange and yellow consume less natural gas, the lower end of the spectrum. And the reason that we in North America become concerned about fossil fuels is because we rely heavily on oil and natural gas, which are both the ones expected to dry up a little bit sooner. All right, so what are our advantages to natural gas? So it's fairly easy to extract and process, not quite as easy to transport, but we're developing an infrastructure. It requires minimal disruption of land because just like oil drilling, you basically just stick your drill way down into the ground and pull up the natural gas whenever you find it. And this is a key one here. Natural gas is considered a cleaner fuel because it produces less air pollution than oil and coal when it's burned. This is because natural gas is made up of smaller molecules, so mainly methane, ethane, propane, and the smaller molecules burn more completely. So they burn all the way down to carbon dioxide instead of partially combusting and having a lot of residual, ash or things behind. So natural gas is considered one of the cleaner fuels. There also aren't as many contaminants, so the lack of contaminants really helps to make sure that there's less air pollution of these, like the sulfur dioxide and nitrogen oxide released when we burn natural gas. Now the disadvantages to natural gas, first of all, there is still hydrogen sulfide and sulfur dioxide that are released during processing if the company is not being careful to make sure that they capture all of their emissions. Methane. Now methane is considered a more harmful greenhouse gas than carbon dioxide because it has a higher greenhouse potential, which means that if you were to take 1 pound of methane and 1 pound of carbon dioxide and put them both in the atmosphere, the pound of methane would trap much more heat than the carbon dioxide would. So if we have natural gas leaks, and if natural gas is being released into the atmosphere because we're using it so much more as a fuel, then we're going to have possibly accelerated global warming because of the increased heat being trapped by that natural gas that's escaping from our processing plants or our extraction facilities. Finally, the process of extracting natural gas in some methods releases a lot of contaminated wastewater and brine, which we'll talk about a little bit later. So this is one of those problems where we want to make sure that as long as we're doing things carefully and protecting the environment, we'll end up being okay. But in places with fewer regulations than the United States, we end up not being okay. So quiz question for you. And this is one that is frequently seen on the AP test. Compared with oil and coal, natural gas is considered a cleaner fuel because A, natural gas contains no sulfur compounds, B, natural gas is much easier to extract and transport, C, natural gas contains smaller hydrocarbons which burn more completely, or D, natural gas does not release any carbon dioxide when burned. So go ahead and think about that. Pause the video recording, choose your answer. And the correct answer is C. Natural gas contains smaller hydrocarbons which burn more completely. We know that natural gas does contain sulfur, so A is wrong. We know that natural gas is not necessarily easier to transport than oil or coal because it's a gas, so B is wrong. And we know that D, natural gas does release carbon dioxide when burned because it's still a carbon compound. So D is incorrect. That leaves us with our answer is C. It's considered cleaner because it burns more completely and is less likely to release some of the other air pollutants. All right, now let's talk briefly about some new sources of natural gas that we've known about for a while. The technology's been there for a while. They're starting to hit the news now, though. This new technology, or a more famous technology now, is called hydraulic fracturing. Now, hydraulic refers to the use of water under pressure, and fracturing means that we're basically splitting something apart. So, as I mentioned earlier, natural gas can become trapped in layers of rock, which means that if you can crack the rock apart, you can get the natural gas out. So what these different companies do is they pump water, sand, and chemicals down into a well that's drilled into shale. Now, the shale is a type of rock formation that has a lot of different little layers, flaky layers of rock. The pressure from the water creates tiny cracks in the rock. The grains of sand hold those tiny cracks open, and then the natural gas is able to escape through the cracks and can be pumped up out of the well. So here is a picture of what this might look like. This is, the water, the truck's bringing the water and the sand here. We have a well that drills down, way deep down, below the aquifers, I have to point out. So this well is drilled below the aquifers, and then down here at the very bottom, they have these big pipes, and they pump the water and the sand and chemicals into, like, out of the pipe and then into the surrounding rock. And then as the sand forces those things open, the gas is able to make its way back out and up the well. And so we collect the dirty water, we collect the gas. The dirty water gets, well, that's part of the problem. The dirty water can be released in a lot of different ways. Sometimes it's discharged straight into the local rivers or ocean. Other times the dirty water is actually processed before it's released or sent off to a sewage treatment plant. So the gas then gets shipped to market. Now, we have the U.S. Department of the Energy Information Administration has put together this map which shows where the major shale formations are in the United States, and these are areas where we believe that we can extract natural gas. So if you notice on the East Coast, there's one over there called the Marcellus Shale. It's highlighted in blue. The Marcellus Shale is one of the largest shale formations in the United States, the largest, and it's believed to contain a huge amount of natural gas. Now, if you look over in California, we have the Monterey Shale. This is the one that's being extracted where they're doing hydraulic fracturing in California. And then you can see Wyoming and Colorado have quite a few shale formations. Texas has quite a few. There's a few found throughout the Midwest. So these are all areas where people are looking for natural gas and considering hydraulic fracturing as a method for extracting that natural gas. Now, the Marcellus Shale in particular is believed to contain about 500 trillion cubic feet of natural gas in that rock. Now, I did a little bit of digging, and our current annual consumption of natural gas in the United States is around 25 trillion cubic feet per year. So if we were able to extract all of the natural gas out of the Marcellus Shale, that alone would be a 15 to 20 year supply of natural gas at our current rates of consumption. So it's no wonder people are very interested in hydraulic fracturing in the Marcellus Shale, because it's believed to be able to produce quite a lot of energy, quite a lot of fuel for us, and then in the process also create quite a lot of jobs. Now, like I said, there are some major issues with fracking. The first one is that the natural gas, the dirty water, and the chemicals can leak out of the wells. They can contaminate the local groundwater, like aquifers, and other people's wells who are using local groundwater as their source of drinking water. And so for that reason, the technology is now under debate. Another one of the problems that I forgot to put on here is that once the dirty water has been pumped down into the well and used and then pumped back out, it has to be disposed of somewhere. And a lot of sewage treatment plants don't have enough capacity to be able to handle all of the water required for fracking. So because of a loophole that was written into the 2005 Energy Act by George Bush and the Congress at the time, the gas companies who are doing the fracking actually don't have to follow the Clean Water Act when they discharge their dirty frack water. So it's a little bit of a way around having to actually obey the current environmental standards. So some companies just discharge the water that they've used for fracking straight into local rivers or to the ocean. So what the debate is now is really should this be allowed? Should people be allowed to dump their dirty water wherever? Is there something else we can do about this? Is there another way we can clean up the process? And really, should they be allowed to frack wherever they can find the gas? Or should there be some regulations that control who does hydraulic fracturing, where they do it, and whether the local people who live in the area have any say in the matter? So, final question for you. One of the largest shale formations in the United States with great potential for natural gas production is A, the Monterey Shale, B, the Marcellus Shale, C, the Texas Shale, or D, the Alaskan Shale. And go ahead and pause a moment, pick your answer. And the correct answer is B, the Marcellus Shale. So hopefully you guys all got that. I'm pretty sure, well, not positive. I'd say there's probably a 75% chance that the name Marcellus Shale will come up on the AP test. It's been getting a lot of publicity lately, and it seems like something that they'd want you guys to know. So hopefully you found this lecture interesting and informative. That's all we have for today. The last one for chapter 12 is going to be the lecture on nuclear fission, so please make sure you watch that one and get caught up on all the wonders that are nuclear technology. Thank you very much, and I will see you in class.